Hello guys, I introduce you Dr. Eureka. Before I tell you what exactly this project is, let me play this video from their project page. That is not a real dog. Okay, so what you have just seen is a robot dog which this project has trained to balance and walk on top of a yoga ball purely in simulation and then transfer zero shot to the real world. No fine tuning, none whatsoever, but it still just works. Dr. Eureka is an LLM agent that writes code to train robot skills in simulation and then writes more code to bridge the difficult simulation reality gap. It fully automates the pipeline from new skill learning to real world deployment. Let me show you another diagram from this project page, which I'll drop the link in video's description. And this is how this Dr. Eureka works. If you keep looking at it, first step, it receives a task and the safety instruction. Let me play it again. I think it receives the task and safety instruction as input. And then also a policy trained on that reward. Secondly, run the Eureka. Thirdly, play policy with various physics parameter to find maximally feasible. Query LLM to generate reasonable domain randomization. And there you go. So towards the end, you got your robot dog walking on the yoga ball. How good is that? Now, if you look at the other details in it, the thing is that this yoga ball task is particularly hard because it is not possible to accurately simulate the bouncy ball surface. Yet, Dr. Eureka has no trouble searching over a vast space of sim to real configurations and enables the dog to steer the ball on various terrains, even walking sideways. Traditionally, the sim to real transfer is achieved by domain randomization, which is a tedious process that requires expert human robotics to stare at every parameter and adjust by hand, and that takes a lot of time, lot of effort, and lot of money too. Frontier LLMs like GPT-4 have tons of built-in physical intuition for friction, damping, stiffness, gravity, etc. So these researchers say that they were really surprised to find that Dr. Eureka can tune these parameters competently and explain its reasoning well, which is amazing. Let me show you one more video out of this project page. Look at these snippets from the project page where this policy is showing the impressive robustness in the real world. Amazing stuff. So if I just stop this one, play this one, look at this. It takes a bit of a time to load. There you go. It's all simulation. Ball is bouncing on the surface. Surface is slightly uneven, but still ball is managing to do that. Let me try this one, maybe. There you go. This is simply amazing. I think that guy also kicked it. Wow. It's all simulation. So if you go through this project page, there are heaps of other examples there. For example, you can check it out. Let me click here, and as soon as I clicked here, you see it has started writing the code and all the reward and DR parameters. Amazing stuff. That reminds me of that competition AWS used to do for AWS SageMaker car racing. Anyway, but the Dr. Eureka has built upon their prior work Eureka, which is the algorithm that teaches a 5-finger robot hand to do pen spinning. It takes one step further on their quest to automate the entire robot learning pipeline by an AI agent system. One model that outputs string will supervise another model that outputs torque control. And the good news is that they have open sourced everything. They have a GitHub repo you can check. They have this project page which you can play around. As you see, the whole code they have written, tons of examples in different formats. They also have some of these safety instructions if you want to play with it, and you can see that it is happening in different settings, so which is totally amazing. Also look at this where um, they are talking about some of the physics involved prior to policy. They have shared all the training detail, which is really awesome. You can create even your own project if you like. So all in all, you can appreciate how good this project is. I am very impressed by it, especially by the fact that transferring policies learned in simulation to the real world is promising strategy for acquiring robot skills at scale. But most of the sim to real approaches typically rely on manual design, and that really makes it very hard. So this project truly investigates using LLMs to automate and accelerate sim to real design. And this LLM guided sim to real approach requires only the physics simulation for the target task and automatically construct suitable reward functions and domain randomization distribution to support real world transfers. So they have demonstrated this in various ways, and truly impressive project. Also, I wanted to share the GitHub repo with you. I will take you there. So in order to access the GitHub repo from this project page, all you need to do is to just click on this code. So let me open it in another window, and I'm going to take you there. So this is a GitHub repo. All the source code is there in DrEureka. And then the beautiful thing is that they also have given you the installation instruction. So you would need at least Ubuntu 20.04. You would need a very good GPU. I don't have it, otherwise I might have tried it out. I will still try it out if it works on my GPU. I will show you in simulation, but I don't think so, but I will try. Anyway, so you see it's a Conda environment. They're just unzipping the file, installing the prerequisites, and then it is just installing the forward locomotion and global walking environment. If you want to use it, you can just simply do the reward generation, and then it is going to take a bit of a time, of course. And then there is a run directory which you can run with the app, and that is going to deploy it with these functions. A lot of steps, but of course you can appreciate this is not a small project. It is quite a hard project, and I have gone through the code structure, very well written. I would highly suggest you also try it out, or just read it through. You will learn a lot by just reading this code. Anyway, that's it. I hope that you enjoyed it. Let me know what do you think. If you like the content, please consider subscribing to the channel. And if you're already subscribed, then please share it among your network, as it helps a lot. Thanks for watching.